you were FaceTiming?
I do take my Harley to, or my moped to Harley Davidson. That's where they changed my car.
I bet you they're like,
They make fun of me. They make fun of me, but then they figure out how fast it goes, and then I think it's awesome.
What's it go?
72 miles.
Wait, do you take on the highway?
No, no, I can.
you ride the Harley.
It's sketchy above 40.
Wait, is
Why would you
it
not? How did you block it?
Is it Vince?
Why would you not?
I would get pulled over.
Top speed with a lighter person on it, I think it's 74.
Wait,
Like that.
wait.
But I'm kind of heavy, so.
Mr.
Ward,
Ward,
You get pulled over. Did
150.
you know that you could go 70 miles an hour on your moped? Yeah, I'm doing it
Mr.
right
Ward,
now.
that's not a moped. That is called a motorcycle.
Yeah.
wait, is it a 50cc or is it a?
No, it's not a moped. It's a
Also,
motorcycle.
do you have that motorcycle
Yeah,
license?
I do.
I was gonna say, because if you get pulled over with
Yeah,
that,
the reason I like it, I don't have to shift gears, it just goes quick.
Mr. Ward, I have my 49cc. I mean, I can cruise with you with it.
Me and Cindy were FaceTiming last night and talking about whether you're leaving. You guys aren't gonna find out anything until
Not until the
day?
last day of school.
Who do you think it's gonna? Who would you put a bet on if you were?
I don't know, I'm
Let's
kind
bet.
of worried it's gonna be me, because they haven't told me.
Oh my god.
So you just
Alright.
haven't told anyone.
Let's go through a couple problems.
He's
Alright.
told the students and
Alright.
Mr. Ward last.
So, alright, here we
All
go.
this just like this morning, did you hear the news?
Alright, hey, so, what we're doing today is we're solving,
Oh,
logarithmic equations, exponential equations, that's kind of our goal. This problem right here is a exponential equation. The goal to solve this is we can change it to a logarithm and actually solve it. The goal today is to show how to do this type of stuff. So we're going to start with just the properties of logarithms, and we'll kind of go through. This is kind of my general outline of what I want to talk about today on the certain types of problems. So basically the thing is, on this this particular problem, this is the ones we've had previously. How we've done these problems is we've done it by a circle method, and we've done, the normal change from an exponential to a logarithm. So this is log base 10 of 8.07 equals x. Okay, that's called circle method for actually solving it. Okay?
you don't have to put the 10 there, do you?
No, and so that's one of the things I want to talk about, is that if it's a base 10, technically you're allowed to just write log of 8.07. And that's your x. Like, that's the answer. That's the exact answer. It's not a decimal approximation. Okay, so that's what I want to get through today. Is I want to talk about how do you know if that's your final answer, if I want a decimal.
Why is that the exact answer?
That's a log base 10.
Yeah, you're trying to figure out what power do you put on a 10 that makes 8.
Yeah, but then can't you just put that in your calculator?
Yeah, you can type it in, but this is the exact answer as opposed to a decimal, which when you type it in, because it's an indeterminate number,
Why?
it would
Mr.
keep
Ward.
going.
How
So,
many times have you had to use something to the 9th decimal though?
yeah, no one never do, so.
Exactly, so would it not be exact enough?
So, it'd be as close as I need it to be, so.
Okay, but
I'll
here's
put it
the
that way.
I
thing.
guess.
Hey, have you ever made anything that you need more than the 9th decimal?
I'm not gonna argue, okay, so, now, next one, let's talk about how we could do this problem differently. So, one of the problems that we've talked about was something like this. I don't know if I did a problem like this the other day, but this is something that I wanted to talk about. Let's go to the fifth. Okay. This type of problem, this one right here, is something that instead of doing it by a logarithm, by that whole circle method, you can do what the book refers to as a change of base, which is a different strategy for solving a logarithm. So what a change of base is you try to use powers to get to change over. So like changing this 9, that's my base. Yeah, changing that to be 3 squared. That's 9, and then changing the 27 on the other side to be 3 to the 3rd power. And why I would want to do that is because now the bases are the same number, if that's possible, and then we can solve it from there. Like, I didn't have to do this problem. The reason being is that there was no way I could change the base to make them the same. Okay. So. All right. Now, when you actually multiply this 2 onto these two numbers, you have to actually distribute. So it's 3 to the 4x plus 4. You have to actually distribute.
Are you squaring or are you just multiplying?
We're just multiplying the powers. That's a law of exponents that you multiply powers on powers. And then over here, when you multiply the powers, you get 3 to the 15th. And then we can solve from there. Now, it may not work out to be a pretty number, which it's not, most definitely, because I just made up the number. But the concept here is that you, since the bases are the same, they can technically drop out, and we're left with 4x plus 4 has to equal 15. So my x will eventually equal 11 over 4.
I'm just saying you brought the whole box today.
That's a.
Yeah, nice.
They got it ready.
Okay, hey, come on. We got too much stuff to cover today. All right, questions at all about the whole change of base idea?
No.
All right, these are the two basic strategies we've had up till this point. That's it. I mean, we've changed problems to logarithms. I've talked about how to change bases. That was like the first day of logarithm. How you could potentially change the bases, and if the bases match, you could just eliminate the bases. The goal today is to look at problems that you can't do that, and there might be multiple variables in a problem, and that's what we're going to be looking at. Okay. So one of the problems I want to look at is this first one. Okay. Okay. Oh, I'm gonna leave that one up there just for a little bit. All right. So here's the first problem that I'd like to cover. And this one is definitely apparent that you can't do that type of strategy, but there's too many variables in the problem, so we have to learn on how to solve it. So here's the first one.
Is this in the book?
Yeah, this is one of the problems in the book. I forget what number, it was just, I pulled it right out of the book, so I was giving you problems that were very close to what you're gonna see. Okay, so this is one out of the textbook that I saw that I want to cover
This
just
is
to make sure.
goofy, Mr. Warren.
Definitely goofy.
No, it's
Mr. Ward, is that a greater than sign on the? No, on the 3 over here.
Oh, I crossed them out. I underlined the bases and I crossed them out, sorry.
Oh, it just
All right.
looked like you were.
Yeah, the bases were the same, so I underlined them and I crossed them. All right, now, on this problem, there's no way to change the bases to be the same number. So what we need to do here is, there's two strategies for this. You're allowed to do what the book refers to as a property of equality, which is something new, where you can do something to both sides of the equation to actually solve it. As long as whatever you do to both sides, you do the same object to both. Like I can add numbers to both sides. I subtract, multiply, divide. You square both sides. You do something. Well, what you're also allowed to do is take the logarithm. You're allowed to take the logarithm of both sides. Because what that'll do,
Yeah.
Log.
that will change the base of your problem to base 10s, so that the problems have the same bases, because now I have base 10s. And then what you're allowed to do is I'm allowed to drop the powers out front because of the new properties we just discussed the other day. Because what I'm actually doing is making this problem with the same base.
I'll take one.
This is what I'm doing, okay? And these are still the same thing, right? That if the bases are the same, you could set the powers equal to each other, and that's the exact strategy that I did there. So that's what I'm doing. Well, when I take the log of both sides, when you take the logarithm of both sides, you're allowed to do the basic properties of logarithms, where you can drop powers out front. So like this 2x plus 1 can drop out front and become, it can multiply on the log 7. That was one of the properties on logarithms. It was called the power rule. And on the other side, you're allowed to drop that power out front.
Log 3.
Okay, good. Now, what we do is you distribute the logs through the powers, because a log of 7 is just a number, right? It's what power you put on a 10 to make 7, it's a decimal. And so if I distribute this log 7, this is just a number, through the parentheses, distribute log 3 through the parentheses, then I can solve for x, because the x won't have any fractions, it won't be in any powers. We can just solve it using algebra 1, because this is just a number. So if you distribute it through, I'll have 2x log 7, right? And I can put it anywhere I want. Plus
1
1 log 7.
So just log 7.
Yeah. And then on the other side, I distribute, I have x log 3 plus 2 log 3. Alright. So what we have is we just have a normal algebra 1 problem, because we've effectively dropped the powers out and we're going to solve. And so the idea is that I'm going to move all the x's to one side. I'll move all the regular digits to the other side, and then I can solve it.
Subtract log 7.
So we're gonna take 2x log 7
minus x log 3.
3.
Equal sign.
Alright, hold on.
Plus.
So stop. Alright, so we moved over the log, log 3, it became negative. We moved over log, I guess log 7, which is 1 log 7. Move that over, and you can put them really anywhere you want, as long as you keep the positive negative signs correct. So I'm going to subtract that 1 log 7. And yeah, I'm keeping the 1 in front of it. You don't need it. You can just write log 7. I just want to keep track of like where the numbers are actually coming from. But again, all I'm doing here is dragging things around. I want to move the x's to one side, the numbers to the other. This is the part.
Log 3 and log 7.
We want to factor out the x first. Because both of these have an x, so it's called the common factor. So it requires factoring. So you need to factor out the x, and then you can divide it across.
How would you try to do that?
So, because again, it's just like if you had two things that were matching, like in algebra 2, you had common factors. You're allowed to take the common factor out of the parenthesis. So here, I'm going to take the x out of that parenthesis.
You should take the log out too.
No, you wouldn't want to do that because the log is actually attached to those numbers.
That's a little
But
bit.
could you do that?
No. So it's attached to numbers because this is just a number. The log is not like a variable, so it's not like something that they have in common. It's just
Log
this is
7
just represents
minus-
a number.
What number is it?
It's
Don't know. It would be whatever. Be some type of fraction that you'd have to put on a 10.
Like a 5 halves?
No. All right, but a vector of x. So what I have is 2 log base 7 plus or
minus.
subtracting log base 3.
Thank
Alright,
you, Mr. Ward.
So again, what I did here is I pulled the x off of both items, so just the x. And so what was left in the parentheses was the 2 in the log 7, the minus in the log 3, and then that is just a number that's attached to x. So you're allowed to divide that number across, and that would be your exact answer. Like if you want to type it in the calculator and get the decimal approximation, whatever it's going to be, that's fine. But this is what we're going into, and this is what I said. Like the stuff we're going into is definitely more challenging than what we previously
2
did.
log 7 minus.
But
Is that why there's not a test over chapter 3?
there's definitely a test for 3. All right. Oh wait, did I? No, I wrote this right.
You wrote that.
2 log 7 minus log 3. All right. So
That's the final answer.
that's the final answer. This is the answer for x that makes this problem work.
Can
So
you
you're
solve
telling me-
that?
So
That's a very complex
Type
answer.
that in the calculator.
yeah, you can type it in.
Yeah, type it in, dude.
What's the number?
But
I
on
don't
the
know,
test,
I don't
would
know.
you want
This
me
be
to?
5 halves.
You know what? I suppose if I'm
On
plugging
the
in
test,
my
would you want me to
computer
put it on my
machine, it'll spit out a
No, I
decimal.
want that. That's what I want. It'll actually on these problems. I believe it says without using a calculator, find the exact result.
So what if I could
of
do that in
the
the
variable? So no. So, but why I'm bringing this up? Because I kind of warned you. Like the stuff we're going into is, it's not super difficult. But it's definitely different enough that it requires a ton of practice. So like tomorrow we're going to be practicing a lot of different problems in class, trying to get better at this so later on this week we can eventually maybe attempt a couple problems out with this. Because again, I'm just showing you a couple different types of problems today. Like the goal is to show you how to do a change of base problem, how to do a problem where you can do this whole thing where you take logs of both sides, how to do factoring in the middle of a problem. And then we still have to do a couple problems where you do the properties of logarithms. We haven't even seen one of those yet. But this is kind of the goal, is to show you some of these problems. Questions?
Remember the thing that we did at the beginning, is that gonna be on the test?
What was that? Explain.
The thing about money.
Yeah, bank accounts and stuff. That's what this section will eventually have in the homework. They have, finding out at what point does a bank account invest into money. So like, if you had a certain money in a bank account, at what
So
point
we're
will
gonna
it reach
use logarithms
50?
with
Yeah,
that?
we have to use logarithms, because you have to drop powers out front to find time.
Mr. Ward,
So.
it's 112.
Okay, it's 112.
One.
Which made sense. It had to be a decimal because I had to make these numbers the same. So it's probably decimals to make them actually work out to be the same number. All right. But anyone still have a question on this one?
We're done for the.
Okay. No. So
One more example.
okay, we have 2 more.
Oh, 2 more, 3.
Are we gonna fly through that real quick?
We're gonna go through pretty quick. Again, I'm trying to give you at least an example of each type that we're gonna be going over the next couple days.
He said 80 minutes. He plays
So we're
80
using
minutes.
new posters.
In other words,
50 now.
No, I was just
Okay.
going for the big.
All right. Next problem here.
Mr. Ward has empty.
It's just water.
All right.
Can we add
Wait,
the
delete
3?
that.
Can we add the 3 over?
Okay.
Can we add the 3 over?
I need that for later. I just remember I
I
had
was
it.
three over, then you
That's
take
not
the
how we
X.
want to
Alright.
go about doing that.
Okay, what?
Add the 3 over.
No. So what we're gonna do on this problem, we're gonna look at this is a different style of problem where you have it almost kind of mimics this problem that you had in algebra class like many years ago. Like this is a problem that you guys had to factor up in algebra 2, where it's a trinomial where you're going
Just kidding.
minus 3 plus 1, right? That's the numbers that break up to be 3 that make 2 in the middle. You break up this x and x. Like that's what we're doing here. But the problem is they have e to the x's. So instead of just the x here, what you're actually going to have is when we factor this apart, it'll have the same strategies. They're going to break it 3, so it's going to be minus 3 plus 1. That'll make the 2 in the middle. But for e to the x and e to the x squared, that's what we have here. Because when you multiply these together, you get e to the 2x.
Is that the answer?
And no. Now this part right here is what you had to get to, right? We factored it apart. But the problem is on this particular problem is that you have to solve for x yet. You have to find the x that makes it 0. So the trick was on this particular problem was to set each of these equal to 0. So e to the x minus 3 set equal to 0.
Plus the 3 over.
E to the x plus 1 equals 0. And then the idea is that you would add this across. So e to the x equals 3. Add this across, e to the x equals negative 1. Or I guess subtract on that one, yes. But we move them over and then you want to solve.
Natural log.
Yeah, and you take a natural log of both sides. So you take natural log of this,
X.
natural log, and so this power drop out front. I'll show you a different way to do that problem here in a second. X, natural log E,
1.09.
natural log 3.
8, 6,
This
1,
part
2,
right
2, 8,
here
9.
cancels out because the natural log means log base E of E, and the only way that works is if the power is 1. So that represents the number 1. So it's 1 times x, which is x. So this is one of your numbers that works.
And that's 1.
And the problem with this,
0.09861228
all right,
You said?
so
I'm normal.
So, what you also have to do on these problems, we also have to plug the numbers back in. Especially when you have a problem like this on factoring, you do have to plug it in to see if it actually does work in the original problem. To see, like, will it cancel out numbers, will it actually work, all that good stuff. So it's one of those problems, it's actually kind of difficult to see, does it actually make the numbers work. This problem right here is impossible.
Can't do it.
You can't do it. There's no way that you can put a power on the number e, or the natural number, which is 2.7 something, right? That's the natural number e. There's no way you can put a power on it that will make it negative. Like you can make it a fraction, you can make them decimals by putting, radicals on them and stuff, but you can't make numbers negative by putting something in the power of it. So this problem doesn't exist.
Why does E equal 2.7?
You can use imaginary numbers.
Yeah, well, that's something that
That's
we know that it's imaginary, right? I agree. It would have to be imaginary, but knowing that it's imaginary means it doesn't exist in the first place.
Negative numbers don't work.
So inevitably,
Exactly.
imaginary numbers are
I told my mom that and she said she agreed, so.
There's
All right.
I'm a math teacher.
Why is E
No,
2.7?
but why can you make up imaginary?
Because it wants to be.
It just fits. It fits when you draw parabolas and you draw shapes. That it's the theoretical number that if you were to slide that graph to a different spot, where it would potentially hit, because it would be like too high. So they're numbers that don't exist, right? They're imaginary. But
So
the
it's
idea is that it would,
theoretically,
in theory,
potentially
represent
not
the
real.
spot where the curve would hit, like the x-axis. That's what
Okay,
imaginary.
Why are we
gravity,
doing
mass
this?
times gravity times height is
They're-
potential
The numbers don't exist on the graph, but the concept, it's representing a concept that would be there if the graph was in a different spot. Does that make sense?
But they're still real.
Yeah, there's still like,
That's a very
They're still made up
daily
numbers, but-
application.
okay, but anyway, now the other reason why this works is I want to show you the other strategy for doing this problem other than taking the natural log of both sides. You can do the little circle method. That the natural log, or I should say, you can do the logarithm if you want. Log base e of -1 equals x, and there's no way you can do this problem. This problem, the answer does not exist.
Fake news.
Okay, it does not exist. And the idea is that why you cannot take logs of negative numbers. It's one of those rules in math you're not allowed to do. It's like taking a square root of a negative. The same concept, like it doesn't
It's
work.
imaginary.
Because what the actual natural number e represents, it represents a curve. and the curve never actually dips below the x-axis. Like it never comes down
It's
here
an asymptote.
at all. Yeah, there is literally a horizontal asymptote there, so it won't allow it to cross the x-axis.
Makes sense.
So there's no way you're going to take a natural or a log of a negative number. It's not going to work.
So what would you want us to put down for the answer on this?
On this one, like you'd only have one solution, and so that would be the concept. That's what we'd have to talk about. So, and again, some of these problems like they work, and that's something we're going to talk about later. Now, the last problem I want to do today, absolute last problem, was to talk about. Okay, we've done all these examples of like what we're going to be doing the next couple days, because obviously this is the intro day to talk about what we're going into. Obviously, the next couple days we'll get better and we'll practice problems, because this obviously you've never seen some of this stuff before. But all I want to talk about today was like why, like what is something that that actually uses this style of math, and I found a problem online that I think we need to discuss, and it's something that hopefully you'll never have to deal with. I pray that you don't, but it's something that is a real number that exists for a reason.
What's it for?
Jail time. Oh my goodness, that's funny.
It's kind of based on that. So,
I know.
all right,
So guess I don't know.
all right. But what this is, this actual number
half
is an exponential
I was
problem.
really bad at it.
Toxic radium.
That does not have to do with jail, actually.
All right. So here's what the number is. Here's the formula that I would like you to write down.
That's a lethal injection.
400,
You're giving us some K in the blood.
12.8.
And then you're going cardiac arrest.
Oh my gosh,
Put
I
your
just
sleep.
said 12.8.
Bananas can kill you by creating a black hole.
All right.
Same thing.
All right. What this is
dog.
this is a risk management formula for exponentials, and what it actually represents. R represents risk. That's a percent of getting in an accident.
This is
X,
insurance rates.
and no, not quite. What X represents is the blood alcohol level that you have at the time.
Thank you.
Is this Dewey's? Oh, Jesus.
So this is your risk. This is your percent or rate of an accident, like the percent of likelihood of getting in an accident. And this is a real number that I guess insurance companies, police departments have eventually been developing over time. That's why certain states have certain laws about what your blood alcohol level can be. I think in Iowa it's 0.08. That's like the blood alcohol level. And what that number is it's based on the risk of risk to others and yourself of what they want to try to minimize. And where that number comes from is, and this is what I kind of found online because I was trying to find something that was kind of useful. What that number actually comes from is the risk that they want, the minimum risk, or I should say the maximum risk they ever want to have somebody have on the road, which is, this number seemed a little high to me, was they wanted the risk to be less than 17%. A risk to yourself and others. Like 17% to some people seems low, to me that seems like incredibly high. 17% chance that you're going to get in an accident before you like get home. Like, that's, to me that's a high number.
Would you play those odds?
No. So, now, here's the idea. How you actually solve this. You divide the 6 over. So this gets 17 divided by 6 equals e to the 12.77x.
That's
Okay?
2.8333333.
Alright. Then you take the natural log of both sides. So, because that's the strategy we've just been talking about, that you can take natural logs of both sides, or logs, or whatever you want. So natural log of 17.6. Natural log of e to the 12.77x. And when you take the natural log of both sides, because you're allowed to do that, you can drop the powers out front. So this is 12.77x natural log e equals the natural log of 17 divided by 16, and that's in
Nope,
parentheses.
6.
6, sorry, 6.
Good call.
Alright, and then the natural log of e goes away.
That cancels.
That goes away, and this number divides over. And so you have the natural log of 17 over 6, and you're dividing by 12.77. And what this is, this x, when you actually type this in your calculator, I'll type it in, this is what your blood alcohol level would be for 17% risk of getting in an accident.
0.081554.
Which is the number that I found online. So, 0.08, say it again.
0.081554719.
There, you're fine. This is blood alcohol level. That's what Iowa set as their maximum blood alcohol level for Iowa.
We calculated for 100%.
For like I think what they say to get a 0.08, and it's having one alcoholic beverage, one single like can, would put you at risk of that. Would put you almost over that for a normal human being. That's somebody that's like, I think they said somebody that's 190 in pound weight. You would instantly be over that, and you're at a 17% risk now that your judgment on the road will actually be impaired. So that doesn't seem like a lot, right? 0.08 is 17% risk of getting in an accident. To me, that's astronomically high. Now, to give you an idea of like what would give you 100% risk.
Can we calculate that?
Yeah. So what would give you 100% on the same scale? And this makes sense for the numbers that they come up with. That they divide this by 6. They get e to the 12.77x.
Where does 12.77
Um,
come from?
Well, we'll actually talk about how you can actually make these problems when you have like numbers for natural growth and decay. We're actually going to talk about in the next section is like how do you make your own problems? How do we come up with these weird like 12.7
Can I make a
numbers?
problem of the probability
So-
of your moped going 60 miles an hour on the way home?
No. So 0%. So now.
That would be cool.
Now, we take the natural log of both sides. I'm just going to cut to the chase, but you go natural log of the 100 divided by 6.
0.22.
You're going to divide by the 12.77, and that's going to equal x. Because I take the natural log of both sides, and we do the whole step. Okay, say it again.
0.2203.
Okay, 0.2203.
Like
That
Okay.
is 100% you're gonna crash.
100%.
Would
At that
be
point,
like
I think they say
100%
at
dead?
0.25, you'll die of alcohol
There you
poisoning.
go.
Holy crap.
Now, to give the concept, okay? Now, this doesn't work like the way, everyone like, if you're doing calculations in your head, you're like, okay, Word has told me to get to this, it's like one beverage, right? It doesn't work this way, it was like, okay, one beverage would give me 0.8, figure out how many can get me here, haha, I'm actually done, okay? No, it doesn't work that way,
It's gobs.
because the concept there,
I'll look it up.
This is a half-life
Your
of
computer's
alcohol.
gonna
yeah,
be flat.
but the idea is that this is affecting your blood and your oxygen levels. So the more you have, it grows
How
exponentially.
much do you weigh?
That affects me. I weigh 195.
190. Okay, we'll go 200.
Okay.
Mr. Worthman.
That's
So,
rounded
no,
down.
that-
If you have 10 drinks, you'll be at 0.19.
0.19. So that hey,
Dead.
so now that concept is scary because one beverage, they've actually done a study on somebody that's 190. One beverage can get you to 0.08. So like the numbers don't make sense that way. And so it definitely affects everyone differently.
Yeah.
But the concept here is like it's 100% guarantee of an accident that you could potentially kill yourself, kill somebody else. That's why like this is a scary number. It's not very far off from that, and that's what all the insurance companies and they've come up with these magical numbers. So eventually, what we're going to do in the next section is figure out how do they make these formulas? Like what made that? How do they set it up? How do we like come up with their own? That's what we're going to look at. We're going to look at how do we make our own. Okay. Okay. The rest of the time today, you can work on your assignment. Page 421. It's due tomorrow. Keep that in mind. You definitely want to work on it today.
Keep that in mind.